Hello, this is the lecture number 7 for the chapter matrices of class 12th, and we are doing the exercise 3.4, and in that we have to find the inverse of a matrix by elementary transformation method. In the last lecture we have done how to find the inverse of a 2 by 2 matrix by using elementary transformation method. In this lecture we'll discuss the 3 by 3 matrix, which is a very important in for the board point of view. Now I'm taking the question number 16, in which the matrix given as 1 3 minus 2 minus 3 0 minus 5 2 5 0, and I've let this matrix as A, and as we know that A is equal to I into A, so replace the matrix value of matrix A in the left hand side, the value of identity matrix of 3 by 3 order in the right hand side, and the matrix A as it is because this is a 3 by 3 order matrix. Now how to find the inverse of a 3 by 3 matrix, and what is the pattern or the steps you have to use to find its inverse. Now what you have to do, you have to convert the identity matrix in the left hand side by using the properties of elementary transformation method in the left hand side and the right hand side. And for in this 3 by 3 order matrix, first of all convert this element as 1, that is A11, you make it 1. Then you make these two elements as 0, that is A21 and A23, to make it 0 in the second and third step. In the fourth step you convert this element as 1, because here is we have 1. Then you make these two elements as 0, that is A12 and A32, you make it 0. After that you convert this element as 1, that is you make A31 as 1, and after that you convert these two elements as 0. So this is the method or the step if you use to convert these elements, then you will get a minimum steps to find the inverse of a 3 by 3 matrix by elementary transformation method. Now in this question we have already 1 here in the place A11. So what you have to do, you have to make these two elements as 0. So how can you make this element as 0? If you see it very carefully, if you multiply the row 1 by 3 and add with the row 2, you will get a 0 here, because we have minus 3 here. Now how can you make this element as 0? If you multiply the row 1 with 2 and subtract from row 3, you will get 0 here. So what I'm doing, I am using as R2 is equal to R2 plus 3 times R1. I multiply this row 1 with 3 and added with row 2. This is the first step you have to use. In the second step, how can you make this element as 0? You multiply R1 with 2 and subtract from R3. So R3 is equal to R3 minus 2 times R1. Now you have to use these properties in the left hand side as well in the right hand side, and be careful with your calculations. Now R2 is equal to R2 plus 3 times R1. So multiply this by 3 and add it with R2, you'll get 0. Multiply this by 3 and add with this R2, you'll get 9. Multiply this element with 3 and add with R2, you'll get minus 11. Now you can do the calculation in the rough column also, but be careful in your calculation. Similarly in the right hand side, multiply this row with 3 and add with this, you'll get multiply this 3 by 1 by 3 and add with this, you'll get 3. Multiply this by 3 and add this is 1, you'll get 1. Multiply this element with 3 and add with this, we'll get 0. Now R3 is equal to R3 minus 2 times R1. So multiply this element by 2 and subtract from this, you will get 0. Multiply this element by 2 and subtract from this, you will get minus 1. Multiply this element with 3 and subtract from this, you will get 2 and subtract from this, you will get 4. Multiply this element with 2 and subtract from this, you will get minus 2. Multiply this element with 2 and subtract from this, you will get 0. So multiply this element with 2 and subtract from this R3, you will get 1. So you have got 1 0 0. Now the next step is to make this element as 1, that is A22 you make at 1, because we have 1 here in the identity matrix, we have 1 here. So the simplest thing, you can make it here 1 by dividing the second row with 9. If you divide the second row with 9, you will get 0 1 minus 11 upon 9, 3 upon 9, 1 upon 9, 0 upon 9, that is 0. So I am dividing the second row by 9. So 0 1 minus 11 upon 9, 3 upon 9, 1 upon 9, 0. This is the step. Now I made it here as 1 because I have to convert these two elements as 0. That is why I converted this element as 1, because we'll get 0 at these two places by simply adding and subtracting to any row and column. So I am making this element 0. So how make this element as 0? R3 is equal to R3 plus R1, R2. Now if we add R2 with R3, you will get 0 here at A32. So R3 is equal to R3 plus R2. So R3 is equal to R3 plus R2, R3 or R2 you add it, 0, you'll get 0, you'll get 4 minus 11 upon 9, you'll get 25 upon 9. You can do the calculation carefully. Now R3 is equal to R2, so minus 2 plus 1 upon 3, you'll get minus 5 upon 3, 0 plus 1 upon 9, you'll get 1 upon 9, 1 plus 0, you'll get 1. So I made it here 0. Now you have to make this element as 0, or rather I have made this element as 1 by dividing the R2 by 25 upon 9, or you can multiply 9 upon 25. The method is same. But you have to make this element 0. By chance I made this element as 1. I multiplied this third row by 9 upon 25, you will get 1 here. So multiplying the third row with 9 upon 25, or you can divide the third row by 25 upon 9, you will get 1 here, because you have to make this element as 1. So dividing the third row with 25 upon 9, or multiplying the third row by 9 upon 25, you will get 0, 0, 1, minus 5 upon 9 multiplied by 29 upon 25, you will get minus 3 upon 5, 1 upon 9 multiplied by 9 upon 25, you will get 1 upon 25, and multiply 1 by 9 upon 25, you will get 9 upon 25. So be careful with the calculation. Now make this element R2 is equal to R2 plus 11 upon 9 with R3. I am making these two elements as 0, then I will make this element as 1. But try to make this element at 0 first. So I am making these two elements as 0. So be very careful how you can make this element as 0. If I multiply the third row with 11 upon 9 and add it to R2, you'll get 0 here. Similarly, if I multiply the third row with 2 and add with R1, you'll get 0 here. So R2 is equal to R2 plus 11 upon 9 R3, and R1 is equal to R1 plus 2 times R3, you'll get 0 here. So by doing this calculation, I am getting multiply this row by 11 upon 9 and adding to this, you'll get 0, 1, 0. Similarly, you have to multiply the second row with 11 upon 9 by this row by 11 upon 9, and adding to this, you are getting minus 2 upon 5, 4 upon 25, 11 upon 25. Because we have the fractions here, so be very careful in your calculations. Now I have to make this element as 1. So how can, 0. So what I have done, R1 is equal to R1 plus 2 times R3. Multiply this row by 2 and add to this. So multiply this by 2 and adding to this, I am getting 1. Multiply this by 2 and adding to this, I am getting 3. Multiply this by 2 and adding to this, I am getting 0. Multiply this by 2 and adding to 1, I am getting this is 1 plus minus 3 upon 5, 1 upon 5. Multiply this element by 2 and adding to R1, I am getting 2 upon 25. Multiplying R2 with 2 and adding to this, I am getting 9 upon 25. So R2 is equal to R2 plus 11 upon 9 R3, and R1 is equal to R1 plus 2 times R3. Now what I have to make this element as 0. So how can make this element as 0? Multiplying the second row by 3 and subtracting from R1. So R1 is equal to R1 minus 3 times R2. Multiply this by R3, multiply the second row with 3 and subtract from 1. This. So multiply this by 3, subtract from this, you will get 0. Multiply this by 3 and subtract from this, you will get 0. Multiply this by 3 and subtract from this, you will get 0. Multiply this by 3 and subtract from this, you will get 1. Multiply this by 3 and subtract from this, you will get 2 minus 2 upon 5. Multiply second row with 3 and subtract from this, you will get minus 3 upon 5. So I am getting A inverse into A, because I is equal to A inverse into A. So this will be A inverse. This will be A inverse. So this will be A inverse. So A inverse into A is equal to I. Therefore, A inverse is equal to this matrix. This matrix. So this is the method to do the 3 by 3 order matrix to find the inverse of it. Now similarly, we can do the question number 17. We have A matrix as 2, 0, minus 1, 5, 1, 0, 0, 1, 3, and IA is equal to I into A. To replace the value of matrix A here, matrix identity matrix here, and A here. Now we have to make this element as 1. So I am trying to make this element as 1, and after that I'll reverse or interchange the row, so I will get the 1 here. So how can you make this element as 1? Multiply the first row by 2 and subtract from R2, you'll get 1 here. So R2 is equal to R2 minus 2 times R1, you'll get 1 here. So multiplying this row by 2 and subtract from this, you'll get 1 here. Multiply this by 2, subtract from this, you'll get 1 here. Multiply this by 2 and subtract from this, you'll get 2 here. Multiply this by 2, subtract from this, you'll get minus 2. Multiply this with 2 and subtract from this, you will get 0. Oh sorry, 1. Multiply this by 2 and subtract, you will get 0. Now you can interchange the second and the first row, you will get 1 in the first column. So R1 and R2 interchange in the left hand side as well in the right hand side. Now what I have to do, I have to make these two elements as 0, and here I have already got 0. So I have to make this element as 0. So how can make it? Multiplying the first row by 2 and subtract from R2. So R2 is equal to R2 minus 2 times R1. So multiply this by 2 and subtract from this, will get 0. Multiply this by 2 and subtract from this, will get minus 2. Subtract this, multiply this by 2 and subtract from this, will get minus 5. Multiply this by 2 and subtract from this, will get 5. Multiply this by 2 and subtract from this, will get minus 2. Multiply this by 2 and subtract from this, will get 0. So I've got 0 and 0 here. Now how can you make this element as 1? Either you divide the whole equation or by minus 2, or rather I have made here R2 is equal to R2 plus R3. I have added R2 plus R3, so I've got minus 1 here. You have to do those, use those property without changing the change you have already made. That is 1, 0, 0 you have made. So you use those property so that these element will not change, should not change rather. So what I have done here, I have added R2 plus R3, so I will get minus 1 here. So R2 is equal to R2 plus R3, I am getting, there is a change in R2, so I am getting 0, minus 1, minus 2, here also 5, minus 2 and 1. Now you can divide the second row by minus 1 or multiply the second row by minus 1, you will get 1 here. So 0, 1, 2, minus 5, 2, 1. Multiplying the second row by minus 1. So I've got 1 here. Now you can make these two elements as 0. How can you make this element as 0? So R1 is equal to R1 minus R2. And how can we make this element as 0? R3 is equal to R3 minus R2. Make these two like this. You will get 0 here. The property you are using the left hand side as well in the right hand side, you have to use in the right hand side also. Now after that you have to make this element as 1, which I have already made. We have made it 1 already without using any property. So step is reduced. Now what you have to do, you have to make these two elements as 0. Now 0 is already there, so you have to make this element as 0. How can you make it 0? R2 is equal to R2 minus 2 times R3. Multiply the third row with 2 and subtract from R2, you'll get 0 here. This. Say it very carefully. Now because it is I, so it must be A inverse into A. Because it is A, so it must be A inverse. So A inverse is equal to this matrix. So this is the elementary row transformation method. Rather, we have used the elementary row transformation properties to find the inverse of 3 by 3 matrix. Okay, we'll discuss the remaining in the next lecture. Thank you.